Good afternoon, students. So last week we have seen the introduction of algebra. What are the topics are there? So what are the 12 units are there? No? So what are the topics and what are the important questions? Already we have discussed about that, and unit 1 also I have started. So in unit 1, I have told what is a set definition. In that, what is a subset, and we have seen some of the types of sets. That is a singleton set we have seen, empty set, and also subset we have seen. On subset, I have told one example problem also, how to find the subset of a, that is number of subsets. We call it as a power set, and it is denoted as P of A. Okay. So even subset, superset, power set, these all topics we have covered. Equal set also I have told, if both the sets A and B are having the same elements, then A and B are known as equal sets. So these all different type of sets we have seen in the so next universal set is there. So universal set means in finding the union and intersection will be there. No, there we use the universal set. Okay. So in types of sets, so one more type is, that is universal set. Universal set. Okay. So universal set means you can consider any set as a universal set. That is a set of natural numbers or integers or any set, that is A, B, C, like that, any set. You can take that set as a universal set. Okay. Any set can be considered as a universal set. Any set can be considered as universal set. Okay. We can take the example, that is a set of natural numbers. If we take 1, 2, 3, 4, so on like this. Okay. This is the set of natural numbers we have. If you take one more set, that is set A is equals to x such that x such that x is a positive integer, that means x square is less than 20. X square is less than 20 means you can write this as it is equals to x such that x, whatever we are doing the x square, that x square value should be less than 20 means 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So which will be greater than 20. So only up to 1, 2, 3, 4 are the elements of the set A. Okay. So we know what is n. N is 1, 2, 3, 4, 5, 6 up to infinity we have. So A is equals to x such that x is a positive integer where x square is less than 20. So if you write this set as a roster form, the values are 1, 2, 3, 4. So whatever the set A is there, this is the subset of this one. Means this set A belongs to natural numbers n. So this, whatever the set is there, n is called as a universal set. Okay. So these belongs to n. These belongs to n. Okay. So whatever the elements we are taking, those belongs to N. Therefore, N is universal set of A. Okay. So like this universal set concept we have. So after this we have cardinality. Cardinality is means number of elements in a set. This in solving the problems we use this concept, that is cardinality. Cardinality in the sense number of elements in a set. In a set. So you can take any example, that is A is equals to 10, 20, 30, 40. These are the elements of the set A. So cardinality of A, we can write cardinality of A, or the symbol will be there, that is mod A. Okay. So means the number of elements is 1, 2, 3, 4. So the cardinality of set A is equals to 4. Okay. So like this we can find the cardinality of the elements in a set. So here after this we have the concept of some operations are there, set operations. So these set operations are similar to the whatever the operations we have seen in the natural numbers. For the natural numbers, we have the operation of addition, subtraction will be there, and also division will be there, multiplication will be there. So like that, whatever the operations we have for the set of, that is whatever the numbers are there, not only for the natural numbers, for any numbers we have the operations are there. So that is we'll do addition, we'll do subtraction, we'll do multiplication, and also we'll do the division. Similarly, way for the sets we have the operations are there. Those operations are called as a union, intersection, difference, and complement are there. So these are called as a set operations. Okay. So first set operation is union. So you might have the knowledge of 10th class sets. There you have studied about what is union, intersection, and also difference, and also complement of a set. Okay. So set operations, in the first one is the union we have. Let's see about, okay. So union means we know if two sets are there, A and B are the two sets, such that if you combine the elements of the two sets, then it is called as a union. Okay. So if two sets A and B are there, from those two sets, if any common elements are there, and if you write as that as one of the set, that is called as A intersection B. Okay. So set operations are set operations, first one is union. We know that is the symbol we use is U. Okay. For union. So we have definition in the textbook. You can see the definition from the textbook. Combining both the set elements under single set. Simple one I am telling. Combining both the set elements under single set. Under single set. This is the just normal definition. Okay. So in your textbook, the definition is that set A and B be any sets. The union of A and B is defined as a set whose elements belongs to either A or B. Okay, we can write A union B as X such that X belongs to A or X belongs to B. Okay, this is the definition of union. So intersection means common elements in both the sets. Okay, intersection symbol is this one. Common elements in both the sets. Okay, so common elements in both the sets. Usually the definition in the textbook is that the intersection of A and B is defined as a set whose elements belongs to both A and B, and written as, we can write A intersection B as like this. A intersection B is equals to X such that X belongs to A and X belongs to B. Means both in A and B, whatever the common elements are there, those common elements can be written as A intersection B. Okay. So if you see the even Venn diagram, so like this. If set A is there, set B is there, whatever the elements that are common in A and B, we call this as A intersection B. Okay. So if it is union means, so whatever like this, all the elements is common in both the elements, no? Combination of all the elements is called as A union B. Okay. So this is A intersection B. Okay. So third one is the disjoint set is there. So you can take here one example. Okay, if set A is equals to 1, 2, 3 and B is equals to 2, 3, 4, 5. Okay. So then A intersection B is equals to common elements. So 2, 3 and here 2, 3. Both are common elements in A and B. So 2, 3 is the common elements, that is A intersection B. Okay. So for union also if you take, that is A and B. Both you have to combine and you have to write. So for this you can take the example here. If A is equals to 1, 2, 3 and B is equals to 4, 5, 6. Okay, then A union B is equals to 1, 2, 3, 4, 5, 6. Okay, so this is the union and this is the intersection we have. Next we have the disjoint set are there. This is the important one. So in theorems and in problems, we'll use this concept. This is called as disjoint set. Disjoint set means if there are no common elements in both the sets. If there are no common elements, in both the sets. So your common elements are there means it is intersection. If no common elements are there means it is disjoint set. So we'll write it as A intersection B is equals to pi. Here pi in the sense is the empty set. Okay. That is, you can take an example. A is equals to 1, 2, 3. And B is equals to what? 4, 5, 6. Are there any common elements? There are no common elements. So A intersection B is equals to, either it is an empty set, we can write like this, or like this. Okay. So this is called as disjoint set. After disjoint set, we have the difference operation. Okay. This is the important one. Difference operation means if A and B are two sets, then A minus B is equals to all the elements of A, but not all the elements of A that are not in B. So only A elements we have to take. If any common element from A, if you have in B, then you should not take that element. That means only the elements that are in A which are not common in B. So that is called as difference operation. So in textbook you have the Definition: the difference of the sets A and B is defined as the set whose elements belongs to A and does not belongs to B. Okay. So that is the fourth one we have. That is the difference operation. So difference operation is, that is symbol we use, that is subtraction symbol minus. Okay. The difference of the sets, the difference of the sets A and B is defined as the set whose elements belongs to A and doesn't belong to B. Okay. We write A minus B as A minus B is equals to X, such that X belongs to A and X does not belongs to B. Okay. Similarly, we have B minus A. B minus A is equals to X, such that X belongs to B and X does not belongs to A. Okay. This is the representation of the difference operation, that is A minus B and B minus A. So you can take one example. Example is equals to, that is A is equals to 1, 2, 3, 4 and B is equals to 4, 5, 6, 7. Okay. So then A minus B is equals to, see what is the definition? The difference of the sets A and B is defined as a set whose elements belongs to A and does not belongs to B. So here 1, 2, 3, 4 are the elements of A and 4, 5, 6, 7 are the elements of B. So A minus B means only the elements in A that are not in B. Here we have only one element, 4 is there, 4 is in the B. So that means in A minus B, 4 will be not there. Only A elements that are not in B, that is called as A minus B. That means 1, 2, 3. Okay. If you see for this one only B minus A. So B minus A means 5, 4, 5, 6, 7 are there. Here 1, 2, 3, 4. That means in both the sets we have 4 as a common element. So you have to eliminate that element. So remaining will be 5, 6, 7. 6, 7. Okay. So like this we have to write, and representation in the Venn diagram is like this. A, B. So like this is A minus B. And if you take B minus A, A, B, this is B minus A. Okay, that means only elements in B, only elements in A. That is the definition of difference operation. Okay, next the important one is that we have complement is there. Complement operation will be there. Complement. Okay. This complement is represented in 3 ways. Okay. So the 3 ways are, that is, we'll write it as A dash or A to the power of C. This is also called as A complement, or in some problems or in some tests we have A to the power of bar will be there. That is also called as complement. This is complement. This is also complement. So it is represented in three ways. So complement means universal set minus set. So complement is equals to, so already we have seen what is universal set. Universal set minus set. So whatever the set is given in the problem, if you subtract the set from the universal set, will whatever the resultant you will get, that will be the complement of the set. Okay. So you can take one example here. So if you take U, that is the universal set as A comma B comma C comma D up till Z elements. Okay. So set A, we need one more set, no? Set A is equals to vowels, that is A, E, I, O, U. So if these are the set A elements, then A complement. So complement of the set we need, no? That is A complement is equals to U minus A. So U minus A means whatever the elements are there in this, you have to subtract them from the universal set. So the remaining elements will be the A complement set. That is B, C, D, E, after that F, G, like this, so on. Okay. So these are the how to find the complement of a set. Okay. So definition you can have in your textbook. That is, let U be the universal set and A be its subset. The complement of A is defined as a set of all those elements of U which does not belongs to A. Okay. The representation is like this. So A complement representation is A complement is equals to X such that X does not belongs to A and X belongs to U and X belongs to U. Okay. This is the representation of complement of a set. So these are the different operations of a set which are useful for solving the problems. And one more operation is there, that is the symmetric difference. So on this, one theorem is also there in the textbook. Sometimes it is asked for 5 marks question. Symmetric difference. That is A delta B will write. It is called as a symmetric difference. So last operation is symmetric difference. Okay. This symmetric difference means all the elements of both the sets other than common elements. All the elements of both the sets other than common elements. That means you have to eliminate the common elements and whatever the remaining elements are there, you have to write them. Example you can take. Example is, that is A is equals to 1, 2, 3, 4 and B is equals to 3, 4, 5, 6, 7. Okay. So here A minus B is only A elements and you have to eliminate the common elements. But here Symmetric difference means in two whatever sets are there, you have to eliminate the common elements and you have to write all the remaining elements in A and B. So it is equals to 1 to common elements are 3, 4, 3, 4. So in this 1, 2 are there and here 5, 6, 7. Okay. So like this we have to find the A delta B. So it is this, you have definition in the textbook. For any sets A and B, the symmetric difference of A and B is defined as a set. So A delta B is defined as A delta B is equals to A minus B union B minus A, or one more is A union B minus A intersection B. Okay. In these two ways, the symbol is called as symmetric difference symbol. Okay. A delta B is equals to this. In two ways it is defined, and the definition of this one is, in simple way, the definition is all the elements of both the sets other than common elements. Okay. So by this we are completing the operations, that is the set operations in the sets. Next we have the relations are there. In the relations, and we know some of the properties are there. Properties of set, that is the associative property, identity property, commutative property we have. Distributive property is there, and also De Morgan's laws are there. So main for us in solving the theorems or in solving the problems, we need to know the what is the identity property and also what are the associative property, commutative property. So associative property, commutative, distributive, some are there. Some properties you can see in textbook. So these properties are important. So for you have the associative property set properties. So first one is associativity. First property is associative property. There is A union B union C is equals to A union B union C. Okay. If three sets are there, A, B, C are three sets, then A union B union C, and also it is equals to A union B union C. You can see with the help of the examples. Okay, this one. And one more with the help of intersection is A intersection B intersection C is equals to A intersection B intersection C. Okay, this is the associative property. Next we have identity property. So identity property is A union pi is equals to A. That is A into any empty set will get the set A only. And next A intersection union. A intersection U is equals to A. A union pi is equals to A. Okay. Next we have commutative. Commutativity. Commutative property. You have seen in 10th standard commutative property. That is A union B is equals to B union A, or A intersection B is equals to B intersection A. Okay. Next, fourth one is the distributive laws are there. Distributive laws will be there. Left hand distributive law will be there, and also right hand distributive law will be there. So distributive law is A union B intersection C is equals to, that is union and also intersection, combination of two will be there. A union B intersection C is equals to A union B, A union B intersection A union C. Okay. This is one property. Next, A union B intersection C is equals to A intersection C union B intersection C. Okay. This is the one property with respect of union and intersection. Union and intersection. And one more is A intersection B union C. So it is A intersection B union A intersection C. Okay. Next, A intersection B union C. That is A union C intersection B union C. Okay, these are the distributive law we have. So one important one is this one, De Morgan's law. De Morgan's law. So these De Morgan's laws are very important. So you can see them as A union B complement is equals to A complement intersection B complement. Next one, A intersection B whole complement is equals to A complement union B complement. Just the reverse of this one. A union B of whole complement is equals to A complement intersection B complement. A intersection B whole complement is equals to A complement union B complement. Okay. And one more is A minus, you are able to see more. So A minus B union C is equals to A minus B intersection A minus C. One more is A minus B intersection C is equals to A minus B union A minus C. Okay. So this De Morgan's law is important, and 1, 2, 3, 4. These 4 properties are very important in solving the problems and also in some doing the proof for the some theorems. And even in second unit we have the concept of group is there. So for that we need to know the concept of what is associative property, what is identity property, what is commutative property, and what is the distributive property. Okay. So this is the important one. This is about the sets we have. Next we have in this unit only we have the that is Cartesian product and relations we have. So relation definition we have. So that you can see in the textbook what is given as a relation. Before the relations we have the Cartesian product. Cartesian product is nothing but if set A will be there and also set B will be there. So if you do A cross B, that is A into B, then whatever the ordered pairs we are getting, those are called as a Cartesian product of that given two sets. Okay. So the Cartesian product of two sets A and B is defined as a, so next in this we have relations is there. So try to remember these all concepts in higher classes also. These all concepts will be useful. So in relations, we have just for your introduction, for your knowledge, just we are telling what is a relation. After that, we have this equivalence relation will be there. So that will be, sometimes it may be asked for any 5 marks question. Just what is the equivalence relation means three relations will be there if any set Any Cartesian product, it is satisfying those three relations, then it is called as equivalence relation. Okay. So next we have relations. So before that, we have the Cartesian product. Cartesian product. So Cartesian product means the Cartesian product of two sets A and B. Cartesian product of A and B is defined as the set of all ordered pairs. You might have remembered what is called as ordered pair. Ordered pair means like this A comma B. So this will be the X element and this will be the Y element. So whenever you are writing the set elements of A and B in the ordered pair as A comma B, we call it as a Cartesian product, where small a belongs to set A and B belongs to set B. Okay, and we denote it by A cross B. So relation means usually we'll write A cross B. So A cross B is equals to the whatever the set builder form is there, that we are writing it as X such A comma B is the ordered pair such that A belongs to A and B belongs to B. So that means it belongs to set B. And we read as A cross B. Okay, this is the definition of the Cartesian product. The Cartesian product of two sets A and B is defined as a set of all ordered pairs A comma B, where A belongs to set A and B belongs to set B, and we denote it by Cartesian product is denoted as A cross B. It is defined as like this, and we read it as A cross B. Okay, so this is the main definition. If you see the definition of what is a relation. Okay, so relation definition means. So one example also we can see how to find the Cartesian product. A cross B is there now. You see one example here. Before that, you see one example. Example is equals to, that is let A is equals to 1, 2, 3. Okay. And B is equals to 4, 5. Okay, sorry. A comma B we can write. Okay. Then find A cross B and B cross A. Okay. So if question is asked like this, then to find A cross B, we need to find the ordered pairs of those two sets. Okay. So how you will find ordered pairs? That is whatever the elements of A are there, you have to make ordered pair with the set B. That is each and every element of A, it should be mapped with this each and every element of B. So we'll write it as 1 comma A, 1 comma B. Okay. Next to 2 comma A, next to 2 comma B, next to 3 comma A, next to 3 comma B, like this. Okay. So whatever the elements are there in set A, you have to pair them with, there is an ordered pair with the set B elements. So this whatever the relation is there, that concept, you have page number 10. Okay. So there one example is there, you can see from there. And if you find B cross A, it is equals to B elements are A comma B, and here 1, 2, 3 are. So B means first element is A, no? A comma 1, A comma 2, A comma 3, next B comma 1, B comma 2, B comma, okay. So if you compare these two, the X, that is A comma B, whatever the set A element is there, it is coming as a set B element, and the other element you are getting as a set A element. So 1 comma A is not equals to A comma 1. 1 comma B is not equals to B comma 1. A comma 2 is not equals to 2 comma A. Okay. Therefore, A cross B, Cartesian product of A and B, A cross B is not equals to B cross A. Okay. So these both will be not equal. So this is about the Cartesian product. If you see the concept of what is a relation. So here the relation is nothing but one Cartesian product will be there and one more set we will see, and we will do the relation between those set A and set B. Okay. So that is relation. Next concept. So if you know what is a Cartesian product, then easily we can understand what is a relation. So you have this definition of relation in the textbook. So in this main equivalence relation, whatever concept is there, that is important. So let A and B be two sets, any subset R. So we'll consider here capital R as a relation in between of two sets. Okay. So if A and B be two sets, any subset R of A cross B is called a relation from A to B. If R is a relation from A to B, we write A relation B to denote A comma B belongs to R. Okay. So this is the normal textbook definition in your textbook. So if you see general definition, so what is a relation means? Relation is nothing but a connection between the two sets. Means you are connecting the two sets with some relation, that is called as a relation definition. Connection or a relationship between two sets or even same set also. Connection between two sets or same set is called as a relations. So these relations, it contains ordered pairs x comma y, where x belongs to set A or and y belongs to set B. Relation R is a subset of Cartesian product A cross B. R is relation, then the inverse of ordered pair gives a change in relation. Okay. So relation is nothing but a simple way, if you see, it is a connection or relation between two sets. Okay. Just you remember simple definition. So in your textbook, you have somewhat the terminology is somewhat different. So, but the main thing is connection or relationship between two sets is called as a relation. Okay. Connection or relationship between two sets or same set is called a relation. Okay. So if you go through the textbook definition, it is you can write the definition. Just understand the definition. That okay. Let A and B be two sets. Any subset R of A cross B is called a relation from A to B. If R is a relation from A to B, we write A or B to denote A comma B belongs to R. Okay. So just I am writing here the definition, that is let A and B be two sets. Any subset of R, any subset R of A cross B is called a relation. Okay, from A to B. From A to B. If R is a relation, from A to B, we write, how we write it? We write as A capital R B. Okay. A capital R B means A relation B. To denote Even like this also we can write A comma B ordered pair belongs to. This is also for symbol for the relation. Okay. That is A, R, B. R is the relation here, A relation B. R we denote it as ordered pair A comma B belongs to R. So here we have R is subset or equals to cross product A cross B. Okay. So if this is the relation definition, then we have inverse relation is there. Inverse relation means just A comma B. If you inverse that one, you will get it as B comma A. Inverse relation and relation both are not same. Okay. The elements will be different in those two sets. Okay, for any R subset are equals to A comma B. For any R subset are equals to A cross B, we define R inverse. That is inverse relation. Okay, R inverse from B to A by, that is R inverse is equals to B comma A such that A relation B is equals to B comma A such that A comma B belongs to R. This is the definition for the inverse relation, that is R inverse equals to, relation means we write A comma B. For inverse relation we write B comma A. This is A relation B, that is A, just we are denoting in different ways of relations. Okay. So if R is here, R is subset or equals to two sets. A and B are two different sets. So if R is subset of same sets, means A is set A is same and also set B also, if it is A only set A, that means itself. So R is subset or equals to set itself, then R is called a binary operation on A. So this is also important one. If R is subset or equals to same set, subset or equals to A cross A. With the set A, we are doing the relation to itself. Then R is called binary operation. So depending on this binary operation, whatever the definition is there, on this we have three types of relations are. So three types of relations are reflexive relation we have, symmetric relation is there, and also third one is the transitive relation. So these three, if it is satisfied by any these three relations are satisfied, then we call that relation as the equivalence relation. Okay. So this concept also in some theorems for doing the proof, this is important. What is the equivalence relation? You should know the concept. And you have to know what is a reflexive relation and what is a symmetric relation, what is a transitive relation. Okay. So equivalence relation means, first one is the types of relations if you see. So first one is reflexive. So reflexive relation means a relation which is mapping to itself. Okay, any element mapped with itself is called as reflexive. Any element mapped with itself is called as a reflexive relation. So this definition is R is said to be reflexive on A if A is relation on A itself. A is relation on itself. Okay. For all A belongs to A. So this is the textbook definition I am telling. R is said to be reflexive on set A if A, whatever the element is there which belongs to set A, if it is mapping to itself, then we call it as a reflexive relation. Okay. Mapping to itself, then we call it as a reflexive relation. So next, the second one, symmetric. Symmetric relation means R is said to be symmetric if A is relation to B, A is relation to B and B is relation to A. Symmetric in the sense A similar to commutative property we have. That is AB is equals to BA. So A is relation to B implies B is relation to A. Okay. For all A comma B belongs to A. So this is called as a symmetric relation. R is said to be symmetric if A is related to B implies B is related to A for all A comma B belongs to A. You can take here one example. So R is there, one relation we have 1 comma 2, 2 comma 1, 3 comma 1, 1 comma. See, check by seeing this, you can say whether it is a symmetric relation or not. Symmetric relation means A is related to B. After that, what is B? B is related to A. Okay. This is symmetric relation. Here, A is related to B, B is related to A. Okay. So this is satisfying the property of symmetric relation. Next, if we go to the third one, it is the transitive relation. Transitive relation. Okay. Next, transitive means A is related to B, B is related to C, then A is related to C. So that is called as transitive property. R is said to be transitive if A is related to B, okay, and B is related to C implies A is related to C. Okay. For all A comma B comma C belongs to A. Set A. Okay. Reflexive, symmetric, and transitive property. It is itself. Okay. With itself, if you do, it is called as a reflexive. If A is related to B and then B is related to A, then it is called as symmetric. If A is related to B, B is related to C, then A is related to C. This is called as transitive relation. Okay. So if these three relations are satisfied by any set R, then we call it as a equivalence relation. R is said to be an equivalence relation on A if it is. So you can write here R is said to be an equivalence relation on A. Okay. If it is reflexive, symmetric, and then transitive. If these three properties are satisfied by any set, then we call it as a equivalence relation. Okay. So some example problems are there in the textbook. You can see them and check whether it is satisfying the all the three relations. There is a reflexive and also symmetric and also transitive relation. Okay. Next, last topic in this unit is the functions we have. So for any theoretical solving theorems are there, no? So there you should know the concept of what is a set, what is a relation, and also what are the functions. So function definitions will be there. So this concepts also you have studied in the lower class, that is the 10th class, and also intermediate you have the concept of functions. Okay, in these functions you should know when the given two sets are there will be there, no? So when we call it as a function, what are the conditions to become a function, and also different types of functions are there. So just we'll see the introduction today. Tomorrow we'll see the types of functions. So some conditions will be there. So to become a function, so that one, those conditions are important. Okay. Just we'll see some introduction today. Functions. So first condition is type of for functions we have whatever the relation between the sets will be there with the help of mappings or transformation. It is function is also one type of relation. Okay. It is also one type of relation between sets. Okay. So that type of relation may be in the form of mappings or transformations. Okay. Transformations. And if one more is that let A and B are two non-empty sets. Let A and B are non-empty. Non-empty in the sense they have some elements. Non-empty sets. Then the mapping. Then the mapping of an element A belongs to A to B belongs to B is known as a function. Okay. So let A and B are two non-empty sets. Let A and B are two non-empty sets. Then the mapping of an element A belongs to set A. A is the element from the set A and B is the element from set B. If you are doing the mapping in between of these two elements, that is known as a function. Okay. So for this, any two sets to become a function, the first thing is we are doing the mapping. And the main one condition is that every element of A should have unique element of B. Okay. So one more condition to become a function is, this is the important one, that is every element of A should have unique in this element. In the unique means it is only one element. It should be mapped to only one element. That is the main important point here for two sets to become a function. Okay, unique element of B. Okay. So usually functions will represent with Venn diagram or graph or plots. So usually in our textbook or for solving the problems or for solving the theorems, we use the functions denotation with the help of the only Venn diagrams. Okay. So for our convenience, it is easy as to know what is a function with the help of a Venn diagrams. So just you will see one example here. So each and every element of A, compulsory whatever the elements of A are there, those elements you have to map with, like this we'll do mapping. This is set A, this is set B, this is called as mapping. Okay, F. So A, B, C are the elements 1, 2, 3. Okay. So the mapping will be like this: 1, B, this is C. Okay. So that means every element A, B, C are the elements. They are having compulsory one mapping with the elements of B, and also A is mapped with B. That means A is mapped with one only single element. B is mapping with single element. C is mapping with single element. So this is a function. So if you have like this A, B, A, B, C, and this is the function F 1, 2, 3. Okay. So if you have like this, okay. So if you, okay, you can see like this also. Okay. See here, A is mapping with two elements. Here, what is the condition? Every element of A should have unique element of B. Means only single element of B, it should be mapped with the element of A. Here you have A is mapping with A is mapping with 1, and also A is mapping with 2. Here B is mapping with 3, C is mapping with 2, only single element. But here A we are getting two elements, that is 1 and 2. So whenever such mapping is there, it is not a function. Not a function. Okay. So compulsory, it should be mapped with only single element. And one more is, so like this if it is there. Yes. Okay. So A, B are having the images as 1 and 2. But C, whatever the element is there, it is not having the image of 3. That means compulsory in set A, all the elements should have compulsory images. Okay, set A should have compulsory images. This is not a function. Okay, so this will be a function. You can see here, C. A, B, if we have A, B, C, 1, 2, 3. Okay. Okay, like this we have. We have all the elements in A, B, C. They have the mappings. But here C is there in B. Set B, it is not having any pre-image. So it will be not considered. Why? Because only the condition is that in set A only, all the elements should have compulsory mapping. But if the mapping is not there in the set B, it will be not considered. Okay. So the condition is that each and every element in the set A should have compulsory image in set B. And also it should have only unique element. This is the function. Okay. So this is the important, and here we have the concept of, this is the domain we have. So whatever the set elements are there, those are called as domain. And this is called as codomain. Okay. Set A elements are called as domain. Set B elements are called as codomain. Okay. Here range means whatever the elements in set B are there, no, those elements having the images in set A, then those elements are called as range. So range is equals to, here if you see 1, 2. Why? Because 3 is not having the image here. 3 image it is not having. So whatever the elements they are having the 3 image, those are called as a range. If you see here, here range is equals to 1, 2, 3. Why? Because all the elements of B, they are having the pre-image here. So which elements have the pre-image? Those elements are called as a range. So range of this set is codomain here, 1, 2, 3. Range of this set is only 1, 2. Okay. So these are the important things, and tomorrow we'll see what are the types of the types of functions, and next we'll start the second unit. That is about the groups we have. What is a group definition and what are the properties that satisfy any set to become a group.